Okay, so this is part 2 of the 1.2c notes on rational exponents, okay? So in these 6 examples, numbers 5 through 10, we're going to leave all our answers in fractional exponents, okay? In the next video, I'll show you how to rationalize and eliminate fractional exponents, specifically in the denominator, okay? Notice here, when you look at these problems, hopefully you're thinking back to the laws of exponents that we learned earlier, okay? Make sure we're using the laws of exponents appropriately. Remember, one of the great things about the laws of exponents is there's no set order of operations for those, okay? It's really up to you on the tack you want to take, all right? So in number 5, we've got the same base a, and we've got both those to a rational power, 1/3 and 7/3. Now, if you'll remember, if we got base times base and they're the same, we can add those exponents. So I can add 1/3 and 7/3, and I get 8/3, okay? Now we're gonna leave fractional exponents. We're gonna leave that as a to the 8/3, okay? Number 6, all the bases are the same, b. So in the numerator, I can add those exponents. That's gonna be b to the 9/5. Denominator is gonna stay the same, okay? Now, if you remember back, I can subtract these exponents, same base. So 9/5 minus 3/5 is 6/5. So the answer there is gonna be b to the 6/5, all right? Now, number 7, we've got a product here. We've got 2, we've got x cubed, we've got y to the 4th. So 3 different factors there. All factors have to be raised to this 3/2 power. So we've got 2 to the 3/2. We've got x cubed to the 3/2. So we're going to multiply those exponents. That's going to give me x to the 9/2. And y to the 4th, okay, to the 3/2. I'm going to multiply those exponents. 4 times 3/2 is 6. So y to the 6th. Okay, these two are going to stay the same, but because I've got this numeric base here, I can simplify this, okay? And I'm going to use my rational exponents to do that, okay? So this is going to be the square root of 2 cubed, okay? Square root of 2 cubed, and then again, the x stays the same, the y stays the same. So this is the square root of 8, and we've simplified that before. Remember, square root of 8 is 4 times 2. Or 2 radical 2. So my answer here is going to be 2 radical 2, x to the 9/2, y to the 6th. Okay, that's the answer for number 7. So a lot of laws of exponents, a lot of simplifying radicals, and a lot of learning how to deal with fractional or rational exponents. All right. Number 8, this whole expression has to be cubed. This expression, I'm just going to clear up this negative exponent and move it to the numerator to make it a positive 1/2. So first things first, the first term here is going to be 2 cubed, c to the 9/4, okay, 3/4 times 3 is 9/4, d to the 1/3 times 3, well, 1/3 times 3 is 1, so there's an understood exponent of 1 there, okay? Again, with the second term here, I'm just moving the c up, so c to the 1/2, d to the 4th. I usually write these in alphabetical order. You don't have to, okay, but it is a good pattern or habit to create to put variables in alphabetical order. So I put the c first because of that. Okay? So now then I'm going to simplify here. I've got a fraction here, a quotient times this expression here. So I've got 2 cubed, which is going to be 8. I've got c to the 9/4 times c to the 1/2. Okay, well, I have to add those. Okay, well, they're not common denominators. They don't have a common denominator. So we would change this to 2/4. Okay, and 2/4 plus 9/4 is 11/4. So c to the 11/4. Now, this d to the 4th is in the numerator. This d to the 1st is in the denominator. So I can subtract those exponents. 4 minus 1 is 3. So d cubed. All right, so that's my answer for number 8. All right, number 9. Let's write both of these using fractional exponents first. Okay, so 2 radical x is 2 times x to the 1/2 power. Notice only the x is to the 1/2 power. This is 2 to the 1st, okay? And then I'm going to have 3 times x to the 1/3, okay? X has an understood exponent of 1 here, so it's going to be 1/3 is my fractional exponent, okay? I can multiply the coefficients together. 2 times 3 is 6. X to the 1/2 times x to the 1/3. I have to combine those using addition. So 1/2 would be 3/6. 1/3 would be 2/6. When I add those, I get 5/6. So my answer is 6 times x to the 5/6 power. Okay. If you need to, out to the side, convert these to a fraction with a denominator of 6. So 3/6 plus 2/6 That's where the 5/6 come from, all right? Here we've got a radical expression inside of a radical expression, okay? So let's do this first. So first thing I'm going to do is I'm going to clean this up. This radical x here is x to the 1/2. So I've still got this big square root. This x hasn't changed. All I've done here is change radical x to the 1/2, okay? Now this whole thing can be combined to x to the 3/2, okay? So I've got the square root of x to the 3/2, all right? So I'm going to write that as x to the 3/2 power to the 1/2 power, okay? Because remember, anything under the square root is to the 1/2 power, all right? So now I can multiply these exponents, so my final answer is going to be x to the 3/4, all right? So that's how you simplify radical expressions using rational exponents, and how you kind of combine the laws of exponents to help you simplify expressions that have rational exponents.